Out again. I created these slides just this last week because the Attorney General for the United States had all of his U.S. attorneys from all over the United States together, and they wanted to know what was the future of forensics. And so because I told them the future and prepared this information, I wanted to share it with you first. So I just told the Attorney General and all their prosecutors Tuesday, right? Yes, Tuesday. So you're getting this 2 days later. But this collaborative approach and an aggressive simultaneous analysis. Now here's the future of forensics. Because hard drives, remember I told you, have gotten so big and they hold so much information, no longer can one person look at one hard drive and it takes them too long and it's too much information. So now the computer programs are getting to where you can put one hard drive up on a forensic server and you can have 2, 3, 4, 5, 10 forensic examiners all examining that one hard drive at the same time, all in a collaborative environment. So if I do a keyword search for explosives, you are also seeing that I did that keyword search and what my results were. If I identify something as significant to the investigation, I find a piece of evidence that I think maybe this is significant, you could have either the head forensic examiner or lead prosecutor that sees the heads-up display or a screen that I'm sorry, this seems to keep going out, so I'll sit down. That will see every time I identify something as of value, they'll actually see it on their screen. That is, again, kind of where we're headed. Also, I told you the server-based environment and push to desktop. We're not there yet, but I figure by next year there's a new program, a new version of FTK out called FTK Lab, and it actually gives us this ability to share our forensics desktop with someone remotely. So that could probably mean the prosecutor, that I could show them my desktop and show them exactly what I'm talking about with the forensic exam. So from this morning, this is just a summary from this morning, we talked that digital evidence is a part of every single crime that we do. It comes in many shapes and sizes. It's not just computers, it's not just hard drives. It could be thumb drives, it could be USB sushi or what have you. We have to have this phased approach to computer forensics. We don't send a computer to the lab to have the forensic analysis done and get no information for the entire time that they're doing the analysis. We're constantly talking as we're finding evidence. And the more we talk, the more valuable our investigative efforts are going to be. And then, of course, we have to do a humanly digestible report. Let me let's see, move to. How many people do you know how hard drives save and delete data? Let me see if I can, I want to go over something. I've used a couple of words I want to make sure that everybody understands. Two big words in forensics, and this is not in your book, two big words in forensics, I'll provide copies to Monica to make sure that you have all these, is logical versus physical. Logical means these are the active files. These are the files that you see on your computer when you're looking at your computer. If you delete a file, it's gone. You would not see that logically. Physical is another term that we use in computer forensics. That stands for every single every bit of that hard drive, even the deleted data. Now, how does information get saved and deleted so that you understand what I mean by can you see something once it's deleted? So that's what I want to go over. When you have a computer and a brand new hard drive and it's empty, you just bought the hard drive, basically that hard drive is like a big book. and it's all blank. All the pages are empty. Now, when you create a document, when you type up a Word document, and let's say I create a document and I call that document Alice, and it's a letter to my friend Alice, and I name that document alice.text. Well, what happens in a computer is as soon as I click save, the computer looks at the hard drive and says, hey, I've got a Word document here that's 7 pages long. I need 7 pages on that hard drive to save this Word document on. Where are the 7 pages that I can use? Your computer's hard drive says, oh, well, page 70 through 77, they're empty. You can save that document there. And so that's what it does. It actually saves that document in page 70 through 77, and in the table of contents, because every book has a table of contents, in the table of contents, in the table of contents, it actually writes alice.text. So now you actually have a table of contents that says the file named alice.text is saved in that book on page 70 through 77, right? Now, if I delete Alice, if I say, okay, I want to get rid of this alice.text file, I don't want anybody to see it anymore, and I click delete, and I empty it from the waste bin. Some people think what happens is it basically completely erases those pages, tears those pages out. But in a computer, that's not how a computer deletes data. What actually happens is it goes to the table of contents that tells you Alice is on page 70 through 77, and all it does is change in the table of contents the first letter of that file name. Now, that tells your computer that that space is empty, but it only changed that in the table of contents. If you went in the book to page 70 through 77, what would you see? You'd see Alice. It's still there. So when you delete a file, you're not actually deleting that file. You're just deleting the name of that file in the table of contents. That's why with forensics, what we do is we don't look at the table of contents. We look at every page in the book, right? And that's how we can see all these files that have been deleted. Now, it gets a little more difficult because what happens if I create another file, and let's call that file Bill, and Bill is 5 pages long. Now, I've deleted Alice, and I created another file called Bill that's 5 pages long. If I click save, if the computer said, hey, well, page 70 through 75 is empty, because OV deleted the alice.text file, and it saved it, then when I looked at that hard drive with my forensic software, I would see on page 70 through 75, the file Bill is there, all 5 pages. What would happen if I looked at page 76 and 77? I would see the last 2 pages of Alice. Remember that Alice was, yes?
Thank you. I'm wondering, do computer programs, will it use up the rest of its space with new programs that you're writing before it overwrites the old Alice files, or will it automatically start rewriting the Alice files since you've marked them deleted?
That's a great question. It actually will not go and write directly to where Alice is. The way the hard drives write is those hard drives are spinning at a minimum of 4,200 revolutions per second. All right, RPM, per minute. And most hard drives spin at 7,200 revolutions per minute. So it saves that document. Can't hear? Do I need to start back? It saves that document wherever that hard drive is spinning. So wherever the blank page is closest to that where the hard drive is going to write at that moment, that's where it's going to write that information. So it's random. So what that means is you don't have to worry that that file is going to be overwritten right away. As a matter of fact, remember, the bigger the hard drive, the much less likely that file is going to be overwritten again. That's the reason we're finding files from well over a year, 2 years ago that were deleted still on the hard drive. It's an amazing amount of information. And just remember, this can still go on, and even if that file does write in that same location as Alice, it has to be larger than Alice, otherwise there are going to be what they call remnants, right? So if I deleted Bill and wrote a file called Cindy that was 2 pages and it saved it in the same location, then you see here, if I looked at it with my forensic software, the first 2 pages would be Cindy, that's the active file that's there. But then if I looked at the rest of the pages, I would see the last 3 pages of Bill that were deleted and the last 2 pages of Alice that were also deleted. So you see how you can get very, very old information from off of the hard drive that was previously deleted. Nothing is ever completely deleted until it is overwritten, completely overwritten. So I would have to create a file that overwrote that whole area that Alice was saved in before Alice would be completely gone. Right? We okay? Now, I wanted to show you a case. Just this is a this is not a real investigation. This is just a scenario that we developed to help our prosecutors understand how we can do forensics and the type of information that can be found. And in this case that we did, and this is just going to show you some of the forensic evidence that can be found to prove what happened on the computer. This is our scenario, and that is that our victim's name is Heather Miller, and she's the daughter of a famous ergonomic chair designer named Herman Miller. And she was kidnapped or abducted by 2 men on February 18th, 2007 at approximately 3 p.m. from the bus stop in front of the high school. The men were wearing masks and rubber gloves. They were tied up with a white rope and sexually assaulted her, so they raped her. And they told her that she was going to be made famous on the internet, right? That she was going to be made famous on the internet. She overheard one of the people that kidnapped her that his name was Peter, because the other one kept calling him Peter. She was also made to drink, this liquid substance that knocked her out. And then she woke up several hours later in a field near her home. And then after reporting to the police that she had been kidnapped and raped, she received this letter on her doorstop, or on her door at her house. It says, if you want to keep breathing, you better stop talking to the police, to the cops, tell them that you made the whole thing up, drop all the charges or you will die. We grabbed you before, or we kidnapped you before, we can do it again, but this time you will not live. And then they included a picture of her when she was being kidnapped. Now this is a picture of a chair that we tied up with white rope because my boss would not trust me to tie up any of the women in the office, just to use as an example. So I don't know why, but either way. So now typically on a forensic exam, your forensic examiner would find pictures and say, hey, I found the pictures and we're done. This is enough. But we want to show you how you can use forensics to prove a little bit more using that Lockhart's principle of evidence transfer, as well as taking that investigative mindset. Rather than just finding the picture, if you think, where was that picture found on the hard drive? So this particular picture is called Bond 3. And this Bond 3, when we look at it, this is the picture, was actually found, look down here at the bottom,